Well, it's a good thing to see so many people here right after lunch. So hopefully I won't put you all to sleep, right? All right. My name is Prem. I work for Barclaycard. If you don't know us in the US, we are the fastest growing credit card provider in the country. In the UK, we are a very large retail bank, but here, credit card services are what we do, right? A little bit about myself. I've been working with Barclaycard for the last 3 years. I lead the engineering team for the global platform. Before that, I used to work for a consultancy called ThoughtWorks. You might know it as Martin Fowler's company, although it's not really Martin Fowler's company, but still, we'll go with that. And my biggest claim to fame, is that I've been working with containers since 1997, right? Well, that might sound a bit of a stretch, but that is indeed a true statement. I've been working with containers, real containers, not Linux containers, since 1997. So I worked on software which would unload containers from ships, load them back, plant them in the yard, and so on and so forth. So, and this was something that I didn't want to let go of. All right. So with that, talking of ships, do you recognize this ship? Anybody? Nope. It's also not the Titanic, if you're thinking about the Titanic. That is the Titanic, right? Now, the Titanic, or actually the RMS Titanic, Royal Merchant Ship, it was manufactured by Harland and Wolff in Ireland, Northern Ireland, Belfast. And it took $7.5 million to build. In today's money, it's close to around $200 million, right? And it could accommodate 3,500 people. At the time, it was the biggest man-made object in the world, right? And it had safety features that exceeded the standards at the time comfortably, right? And it was deemed to be practically unsinkable, right? But we all know what happened to it, right? On its maiden voyage, it sank, right? And it sank pretty good. It killed 1,500 of the 2,200 people on board, right? It took 2 hours and 40 minutes to go down, but it did go down, and with it went all of the 200 million, or in those days, 7.5 million with it, right? Now, yep, it got wrecked, right? Coming back to this ship, right, was made by the same company, Harland and Wolff, for the same company as well. It was made for White Star Line, right? Same company that bought Titanic. It was made around the same time. They actually made 3 ships. This one is called the Britannic, His Majesty's hospital ship, the Britannic. Guess what happened to this ship? Sank again, right? But this time it lasted 3 voyages. On its 3rd voyage, in the First World War, it was used as a hospital ship, and it was carrying patients in somewhere close to Greece, in the Key Channel, and it sank. It got hit by an underwater mine, and that was the end of that, right? Now, if you're White Star Line, or if you're Harland and Wolff, that's not really good for you, right? 2 of the biggest ocean liners that you build both go down in double quick time, right? The 3rd one, it was called Olympic. That did actually last until 1935, after which it was decommissioned. So it did go through the full life cycle, right? So let's examine what happened to these ships, right? If you look at a ship, right? Even today, this is true. Ships have these things called bulkheads. These are watertight compartments because it's occasionally possible for water to get into these ships, right? And so what they do to isolate water, getting into the entire ship, is that they build these watertight compartments called bulkheads. And it turns out that when the Titanic had a glancing blow and hit that iceberg, it actually developed holes in 5 of the 16 compartments. So apparently it could withstand up to 4, but it had problems in 5. And then water started gushing in at around 7 tons per second. And in 2 hours and 40 minutes, that was the end of that, right? So what is the point of all of this? Why are we talking about sunken ships? We're talking about sunken ships because this guy said 50 years later that the times are a-changing, right? That's Bob Dylan, by the way. So really, the point is about isolation, or the lack thereof. The Titanic and the Britannic went down because they could not isolate failure in components of the entire system. The bulkheads failed, and now took the ship down along with it, right? So the point of all of this is that for us to build resilient systems, we need isolation. It has been the cornerstone of one of the most successful products in history, the Unix operating system, right? It embraces the single responsibility principle, which states that every component will have one and only one responsibility and will do that one thing really, really well. Isolation enables quite a few things. One of them is autonomy. Right now, you can have these really small teams that are able to innovate independent of the other, which means that we can build speed, which means that it's lower risk and results in faster value. And if you're a business person, faster value is what you want to hear, right? So how do we do that? So I'll walk through our journey, and then I'll talk about what pitfalls and what gochas we encountered. Hopefully, you'll find it interesting. So we started with this one big monolith, like pretty much every bank. Juniper Bank was created in 2004. Like every other company, we started with this one big app. We have this thing called the credit card service, which has close to around 600 methods in it. Pretty much runs the entire bank, right? Not all of it is being used today, but it still is in production, even now, after 13 years, right? So we could obviously not scale this, so we went down the route of saying, OK, we're going to take one of these modules in the credit card service and push it out, right? And it still talked to the same shared database, but this was still OK, right? Now, we did this. We saw some success. So we said, for true isolation, what we want is we want to take the database and push it so that the component that we just extracted out has its own database. So now it encapsulates the data and does not get affected when other components try to update its data, right? We saw some success here, so we started doing this a bit more aggressively, right? And we pretty much did this for a lot of our components. So we have this nice-looking system where all of these services are now broken down into each of their components. They have their own data, so you can't actually talk to any database directly. To talk to anything, you have to talk to a service first, and it'll give you whatever data you want to operate on. But this did pose a problem. In the previous incarnation, when we had one big database, now if you needed data, you could just go get it from the database because you already were connected to the database. Now you can't do that anymore. You couldn't do that anymore. So what you had to do is you had to make service calls. Now these were remote service calls, and now sometimes what would happen was we would have cyclic dependencies, right? So again, back to the drawing board as far as isolation is concerned. Now we are back in the same place where we do not have isolation, although we have got a bunch of remote components. So what we did was we said, OK, fine, we don't want this, so we are going to create this thing called an event bus. Now, every component that makes some change or does something interesting would do that thing interesting, write to its database, and then publish an event on the event bus. Other components downstream would listen to those events and they would react to that, and they would store whatever data that they were interested in. So this way, the publisher didn't care about the subscribers. So we have gained the isolation that we were looking for. But now what that meant was our UIs now, which would now make a single service call to get most of the data, had to make more than one service call, right? So they started doing orchestration. They started having to make multiple calls, aggregate data, and then present information to the users. So this, again, was a problem, because now you don't want too much UI logic in your frontiers. So we said, OK, fine, we don't want that. We'll introduce a component, call it the API gateway, make that do all of this orchestration. But we also are a bank. A lot of our systems are about integrating with third parties, vendors, legacy systems. You go try telling them that that we have this shiny event-based system, and now you have to do events. I mean, they'll laugh you out of the door, right? So what we had to do was we built these things called gateways, which were really anti-corruption layers, which would translate events on the way in and translate into whatever the third-party system would understand. So if it was file-based integration, if it was messaging, if it was a batch-based system, what have you, right? So the gateways would now shield all of our core systems from these core systems from our third parties. This also allowed us to produce systems where we became largely independent of these vendor systems. So we could swap out one vendor for another, at least in theory, right? We went one step further by saying, looking at a single service. If you look at operations on a service, you've got two kinds of operations at a high level. One, you've got operations that mutate things, and others that actually ask for things. So commands and queries, right? Statistically, we saw that for every command, there are at least around 40 queries, right? So it makes sense for us to now split the command side and the query side. So if you remember the Datomic folks, or was it Cognitect, right? Justin from Cognitect, he mentioned Datomic. So there are stores that are specifically created and designed to store immutable streams and events of data. So that's what goes into our command store. And then when we publish out events, you can now store several representations of that same data. So if you want to create that report that your boss wants, you can look at the data in your event store and then now create a new query store, right? So all of this looks great, right? This was finally our free lunch moment, right? But you know what they say about free lunch. So there are things that you might want to watch out for. So when you're splitting your system, right, how you split your system is very important. And domain-driven design and Eric Evans have some really, really good advice about what to do when you're trying to split your system. Because if you do split your system, and if you do it the wrong way, then what looks like Hershey's Kisses to me may look like something else to you, right? And now you'll have a lot more of those, right? So definitely get your domain architects, get your product owners, folks who know your systems intimately, get them in a room, and then decide how you want to split your systems, right? Another thing that you have to get used to is eventual consistency. Now, because things happen in reaction to events, it means that your command side and your query side may be out of sync for, albeit a very small amount of time, but they will still be out of sync, right? So you have to get used to that. If that doesn't work for you, then this way of splitting probably does not work for you either, right? So, but it did for us. So a lot of our systems are embracing this, right from our services to our UIs to our business folks are aware that our systems are built in a way that they are eventually consistent. Compensating actions, right? In a monolithic system where you've got one big large database, you can always do a bunch of things and then roll them back. But in a distributed system, you can't do that. You actually have to think about failure scenarios, and you have to compensate for them. So think about failure scenarios and how you want to compensate for them from a business perspective so that you're not having to have developers write SQL queries in the middle of the night, right? So again, something that you have to absolutely think about. Another thing is event ordering. Event ordering is extremely important. You either rely on an event order or you don't. If you do rely on an event order, then you might find yourself in a little bit of trouble. If you do not rely on event order, then you have to write systems which are idempotent and are resilient to things happening slightly out of order. The final thing that I have here is observability. You've got a large distributed system. You need to be able to see what is going on where, and when things are going wrong, you need to know where they're going wrong exactly, right? The weakest link in your system can actually let you down. And again, there were folks who presented earlier in the morning where you need to have health checks, log aggregation, distributed tracing, dashboards, monitoring, alerting, and all of the surrounding infrastructure to help you out. So Martin Fowler said this, right? Adopting this style of architecture requires that you need to be tall enough. So the question is, are you tall enough? And if you are, then again, what's the point? The point is that the times are changing, and you need to adopt, otherwise you may not exist. Thank you very much. What data model do you use to define services? Well, I mean, we've got two kinds of data models. On the command side, we use a thing called event sourcing, where we actually store the events in their true form, and events are immutable. We just store them. On the read side, it's pretty much what our clients need. So it's almost exactly what our clients want. So then there's no transformation. It's really, really fast. Do you use both internal and external cloud providers for hosting microservices? Well, right now we are using an internal cloud based on OpenStack. We are looking to transition over to AWS or something equivalent. But we are building services on top of something like OpenShift, which allows us to be cloud agnostic. Does this architecture help you to release faster products to the market? If so, how much has it improved it? So the way that it helps is we've got domains that allow us to build logic in those specific areas and those specific areas only. So the only place to write domain logic is on the command side. So there is no ambiguity. You've got a separate model for the query side, and on the query side, you've got absolutely no logic. So in fact, once you get over the hump of getting used to this style of programming, and it is a bit of a hump, right? Producing functionality is, I don't know how to quantify it, but we are able to produce a new functionality in a matter of hours, given that you have all of the other infrastructure in place. Do you trace requests through multiple services? If yes, how? Yes, we do have to trace requests through multiple services. We use tools like Elk. Zipkin is another tool that we are in the process of putting into production. It's not in production yet, but we have a homegrown tool that is equivalent to Elk that we use. What API gateway provider do you use? We wrote our own API gateway. Right now, we're using, it's based on Netflix's open source stack, Netflix Zool. It's based on that. We are looking at something called MuleSoft in that space, but don't know if we'll actually move to it. But right now in production, it's Netflix Zool. How do you isolate failure and stop one bad service from affecting the rest of the system? Now, if you look at how things are structured, the service stack, you've got a command side, you've got a query side, and each service has a command and a query side. Now, if one of these components is experiencing failure, it means that just that component is either not able to publish commands, or it's not able to service queries, right? That just means that other portions of the system just continue to work as if nothing else happened. So they're truly isolated except for the event bus. Now the event bus, if you observed, is that one single point of failure. But we take care to put no logic. And when I say no logic, it's zero logic in the event bus. It's just a means of transport. And there are quite a few solutions out there in the wild that actually allow you to scale and make the event bus very, very resilient. So for example, there is Kafka, right, which is very popular these days. And that's all I have. Thank you very much. If you have more questions, please feel free to reach out. Thank you.